Hi there grade 9s and welcome to WorksheetCloud Maths. I hope you're all well today and excited for today's lesson. So let's get started. We are going to be looking at organizing and representing data, and in particular today we are going to be looking at scatter plots. So let's just have a look at what a scatter plot is or why we would use it. So we talk about bivariate data, and that has two variables, and so we represent them by using a scatter plot. Now these two variables, we have variables with anything that we plot on a line graph, and here we're not going to create a line graph as such, but we are going to create individual points, and that's why it's called a scatter plot. So each point on a line graph also has two variables. It has the x variable and the y variable, but generally it creates a straight line or a curved line, but here we are going to look at individual points. So when we are using a formula on a line graph, we would know what the x is and be able to work out what the y is and then plot them to form some kind of a line. All right, and that formula would be the name of the line. Here we are not going to do that, and you will see as we go along how it is different. Okay, so a scatter plot will show whether or not there is a relationship between two variables. Now, like I said, on a line graph, there is a relationship, and that relationship forms the formula. Here, there is no formula. It is just 2 points that make up data. All right. So to represent this data, as I said just now, we're going to use a Cartesian plane to plot the points. Now with the line graph, we also used a Cartesian plane to plot the points, but it was in the form of following a formula. Here we are not going to, and I will show you just now how these two variables create the point. Okay, so when we are doing scatter plots, we are going to use a thing called the line of best fit. And let's just explain what that is. A scatter plot can include a line of best fit that is drawn through the data. This is the line that best represents the relationship, if any, between two variables. A line of best fit is drawn through the scatter plot in such a way as to ensure that any points not on the line are equally distributed above and below the line. So when you draw a line of best fit, it's actually what they say an eyeball look. And we try and look and see that the line of best fit is going to divide the scatter points so that there is as many above the line as there are below the line. So it's more like a feeling that you get of where the line of best fit goes. And just to say right now, it doesn't have to always start at the point of origin, so where x and y are both naught. It doesn't necessarily start there. It depends on the data that you have collected or that you have plotted. Okay, right, so describing the trend in a scatter plot and the correlation between two variables. So here is a scatter plot, and as you can see, there are just points all over the graph. Okay, so now the variables in the scatter plot show some association. So they are related in some way. As the one increases, so does the other. In other words, as the x increases, so does the y value increase. And as the x would decrease, so the y value would decrease. So it is possible here to draw a line of best fit. There we go. Can you see it doesn't start at naught? It starts at 1, and we have 1, 2, 3, 4 above and 1, 2, 3, 4 below the line. And so actually that is the line that best fits that data. So it almost divides the data in half. So now what we can say is that that is a positive association, because as the one point increases, so does the other one. As the one coordinate increases, so does the other one. So that has two coordinates. As we know, a point also always has two coordinates. In this case, it is 1 and 2. Our x value is 1 and our y value is 2. Here, our x value is 1.5 and our y value is also 1.5. And so you can see how they are scattered all over the graph. We're not going to try and join them by using a solid line because they are different. They're actually just scattered points, but we can say they have a relationship, and the relationship is positive. So the association, or we can call it the trend, is positive. Okay, so we can say there is a positive association or correlation or trend between the two variables because both variables increase. All right, so here it was 1 and 2, and there it was 2 and 1.5. Okay, so your x variable has increased and your y variable has come down a little bit, but it's actually moved along. So your x variable has increased. Okay. So, is there an association here? All right, so here there is an association. You can draw a line of best fit, but now it's not in the positive direction. As you can see, if you draw a line of best fit, it's going to come down here and it's going to be negative. So there's an association between the variables, but in this case, as the x variable is increasing, the y variable is decreasing. And so this would be a negative line. There's your line of best fit. Can you see once again? It doesn't start at the naught. Okay, it starts at where you would see it would go through the data best. Right, so the line of best fit here shows a negative correlation. Right, because as it says, as the x variable is increasing, the y variable is decreasing. And as you could see there, it is a negative gradient. So therefore, in other words, your line of best fit has a negative gradient. So it shows a negative correlation, or you can say it's a negative association, or it's a negative trend. Okay, it is quite a strong trend because the scatter points are right near the line of best fit. If they were all over here and all over here, it would still be negative, but it wouldn't be a strong negative. It would just be negative. All right. So what about on this graph? Okay, there we have scatter points all over the place. Can we draw a line of best fit? Probably not, because if you draw one up this way or one down this way, it's going to give you the same amount of points on the above the line and below the line. So if we look at a negative line, we'll probably go from here and draw it down there. Can you see there's a whole lot of points above and below, but we can do the same with a positive. So actually what that shows us is that there's no association. So the points in this scatter plot show no trend. We can't say it's negative, we can't say it's positive, and we can't even say that the one increases while the other one decreases, because the points are completely scattered all over the graph. So we say it shows no trend. Okay, and a lot of the time we use these scatter plots to actually predict what's going to happen. And when we go through some of the examples, you will see how this actually works. All right, so they are scattered in such a way that it is not possible to draw a straight line to show an association, as I said just now. Right, we say there's no correlation between the variables, we can say there's no trend, or we can say there's no association. All of those words can be used to describe what's happening in a scatter plot. Okay, so let's put this into practice because I feel like I've given you a lot of information and I think you now need to see how it actually works. Alright, so the table gives the percentages obtained by learners in the same class for the subjects home language and first additional language. Okay, so what we've done here is we can look at the table just now, but what we would have done here is taken learners and one learner's marks for home language and first additional language and plotted that. Okay, and then another learner the same thing, and another third learner the same thing. And we want to see if there's any relationship between the two. Because clearly, if all the learners were showing the same relationship, then we could actually try and predict the last learner, what theirs would be, or we could actually say that basically if learners, if there is a correlation and it's a strong positive correlation, it probably would be that learners have a language affinity. In other words, they are good at languages because they have got the same for the home language and the first additional language. In other words, it is very close, the marks. All right, so there is the table. You can see they're just arbitrary learners, A to J, and the home language, those are their percentages for the home language. And first additional language, that's the percentage for the first additional language. Now, if we just have a look at that data, we can actually see that we can probably already tell what's going to happen. Why? Because actually this learner A has got very similar marks for home language, or actually the same marks for home language and first additional language. Learner B hasn't got very good marks here, but they're both not very good. Here they are very close, both A's. Here they're down again. There's a bit of a discrepancy. Here they're pretty similar in the same range. Here they're very similar in the same range. Here again, and here. So we can probably say that there is going to be a positive association here. But let's plot this. Okay, so we're going to draw a scatter plot for the pairs of marks, and then we're going to draw a line of best fit through the points of the plot. Then we need to describe the association that is obtained from this. Okay, and lastly, what can you conclude about the correlation between the mark for the home language and that for the first additional language? All right, so let's start first, because now we've got our data. And guys, if you wanted to, you could actually use your own data and your own marks from when you were, say, in grade 6 and look at home language and first additional language from grade 6, grade 7, grade 8, and grade 9 and see if there's a trend developing. Okay, right, so we've put the table in the corner there so we have some space. We're going to draw a scatter plot for the pairs of marks. So remember, the first thing we need to do is we need to have a Cartesian plane, and then we need to plot. Now, I know you know how to do this because you have been actually doing this for quite a while, but what we're going to do is just show the graph. Okay, so there is the graph that shows this information. So learner A is 84, 84. It's not going to start down here, guys. Okay, here's 84 and there's 84, so that is the point for learner A. Because these are not in any particular order. It could be in alphabetical order. So when you plot, it's going to end up being scattered all over the place. Why? Because we are also not following a formula. We're following given data. All right, so there we've drawn our scatter plot for the pairs of marks. And like I said, you can see here's the 84 for the home language, and there's the 84 for the first additional language. And that is how you plot on a scatter plot. Okay, so now we're going to draw in the line of best fit. Can you think where the line of best fit could be? Let's draw it in and see. Okay, so here we can say we are starting from the point of origin, from the 0, 0, and you can see there's 1, 2, 3, 4, 5 below, and 1, 2, 3, 4, 5 above. This one is actually on the line, but it pretty much tells us that that it is the line of best fit because it's sort of in the middle of the data of the dots. Okay, so that would be your line of best fit. And the next thing is you need to describe the association obtained. So it is a positive correlation, it's a positive trend, or it's a positive association. Any one of those terms is absolutely perfect to use. Okay, it is fairly strong, because some of them are quite close. Some of the points are quite close to the line of best fit. There's another one that's close, and these three are close, and then they're a bit more scattered. That one is even close. So it is pretty strong, this correlation. And let's see, what can you conclude about the correlation between the mark for home language and that for the first additional language? Well, let's see. We can conclude that those learners who scored highly in the home language also scored highly in the first additional language. So it is most likely that if a learner scored highly in the one language, they would do the same in the other language. And like I said, guys, you could almost use your own data to test this out and see if that works for you or if it comes up as being completely different. What we generally do say about learners, and I'm sure you've heard lots of people saying this, is somebody is good at languages. So generally, if you've done well in one language, you would have done okay in the other language, or you would have done in a similar range. It's very rare that you would be scoring very highly in one language and very low in the other language. Okay, and actually it's the same with maths and science. People often say if you score highly in maths, you'll also score highly in science. So maybe you should do that as an exercise. Take a whole lot of friends, get their results for maths and science, and see if there's a correlation there too. Okay, let's have a look at another scenario. Okay, a paper manufacturer measured the trunk diameter at chest height, so we're going to see that as DCH on the graph, and the height of the wattle trees in a plantation that they own. So if somebody stands next to the tree, they measure the diameter of the tree at chest height. Okay, so it would be through the middle of the tree, and obviously you could use a circumference to break it down and get back to the diameter, or work out the diameter. And then measuring the height of the actual wattle tree. So is there a correlation between how high it is as to how wide it is at chest height? And chest height would actually be a person's chest height. So generally you'd have to use the same person to walk around and measure the wattle trees. Okay, so they did this in a plantation that they own, and here's the data that they obtained. So there's the table. Again, the wattle trees are random trees. They are just labeled A to J again, and DCH, remember, is diameter at chest height, and that was in centimeters, but the height of the wattle tree was measured in meters. And in this case, it really doesn't matter that it's actually different measurement or units of measurement. Okay, so what do we have to do? We have to plot the data and label the axes. We have to discuss the trend that you see, and we have to discuss how strong this trend is. All right, and then draw the line of best fit. Okay, so here we have our data again, and let's plot the data and label the axes. So there's the data plotted, and you can see that the axes have been labeled. There's DCH for diameter at chest height and the actual height of the wattle tree, and there is all our data that has been plotted. Okay, so our points 13,7 and 10,6 is 1 point. Okay, right, so there we have our data, and we have to discuss the trend that you see. So without drawing the line of best fit, can you see a trend? Well, yes, you can, because you're going to look from the y-axis and you're going to see that it actually does go up. It is a positive trend. Okay, so this trend that can be seen as a positive trend, such that as the wattle tree grows higher, the diameter at chest height increases. Okay, so as the wattle tree is taller, this is its height in meters. As it grows taller, so the diameter gets bigger. Okay, discuss how strong the trend is. Right, the trend is a strong trend because it is actually going to be quite close to the line of best fit. It is actually better to put in the line of best fit first, but we are seeing if we can predict this. Okay, and then draw in the line of best fit, and there we go. There is the line of best fit. All right, and now you can see that it is a positive trend, definitely, and you can see that it is quite strong because the points are quite close to the line of best fit. Right, let's look at another scenario. So here's another example. A survey was taken to show the reaction time in seconds of athletes at the start of a 100-meter sprint at the Olympic Games against the time taken to complete the 100-meter sprint. And here are the results. So just before I show you the results, as you can see, what they've done is they've recorded the start of the sprint. So like the taking off and how fast that was in seconds, and then how far it was, or how quick it was to complete the whole race, also in seconds, for the whole 100-meter sprint. And to see if an athlete starts very quickly, will their time be quick as well, or do they slow down? But let's have a look at the results. Okay, so there's the table, and as you can see, the reaction time in seconds and the time taken to complete the race. All right, so plot the data and label the axes, describe the association, if any, and that's only two things that we need to do. So let's first look at the data, at the plotting of the data. And there we can see the reaction time in seconds and the time taken to finish the race. Okay, so as you can see, if we're looking at all that data, it's very, very scattered. I doubt very much whether we would be able to put in a line of best fit. So is there any association, or describe it? I would say that there's no correlation, there's no trend, there's no association between the reaction time and the time taken to complete the race. Because actually it is very, very different. So some athletes probably started very quickly, but actually didn't complete the race in the same force of time, if I can put it like that. because generally what you would think is if the athlete started very quickly, their time would also be quick. But maybe some they have a very good start, but actually end up slowing down a bit, where others that have started a bit slower end up gaining momentum and finishing quickly. Right, so here there is no correlation. You can see it is scattered all over the place. So we can generally say that we can't actually predict anything from this graph. We can't say that if athletes start quickly, they're going to finish quickly, or they're going to finish strong, if you can even put it like that. Or if they start slowly, they will be the last ones to finish. Okay, so there's no correlation. And it's quite all right on a graph to say that there's no correlation, because these scatter plots we use to predict certain things. So like I said earlier on in the lesson, find your own data and see if you can predict something from that data, or if there's no correlation or no trend at all. Right, guys. There we go. There's a point that's way out there, and we call that point an outlier. Because actually what an outlier is an observation that is numerically distant from the rest of the data. So it is way out. Generally what we would look for, where we would look for an outlier, is where there is a line of best fit, but there's one point that is way, way, way out. That doesn't come close to the line of best fit, because that is numerically distant from the rest of the data. But here, that's also an outlier. As you can see, it's way away from the rest of the data, so it doesn't really fit with the whole set of data. It's an outlier. It lies way out of the main points. All right. Thanks so much for watching this lesson, guys. I hope you've learned something, and I hope you've enjoyed this lesson. If you're doing this at school at the moment, I hope this has brought some light onto the subject, and that you can now understand a little bit better about what is going on at school. Right, guys. Till next time, keep well, and I can't wait to be together again.